Hello, Math 30s. This is the last unit now that we're going to be doing. It's called probability, and it's something that you guys will still find pretty relatable. So I tried to record the next two lessons all as one, and then it turned into a heckin' time, so I'm just going to do this. The first lesson will be pretty short, actually, and then the second one will be a little bit longer, and there are the appropriate questions within your books to support that. So in your notes package, so hopefully you've printed that off, the first lesson is called Experimental versus Theoretical Probability. So sorry, I don't have it here in the Smart Notebook file, but it's saying the mathematical way of defining chance is probability. So when you're saying something like, what are the chances of something? What we're actually talking about is the probability of something occurring. So probability is the ratio of the desired outcomes to all possible outcomes. So in this unit, we're going to focus on probability as the ratio of desired outcomes related to all possible outcomes. So it says there in investigation, so using either a die or technology, roll a die 20 times and fill in the table below. So usually on a regular time, I give you guys all dice and we roll 20 times and we tick off in our little charts. Oh, we got a 1, oh, we got a 2, oh, we got another 2, oh, we got a 3, and we tick it all off. What I'm going to do though is I'm going to just use GeoGebra. So this is just a simulator for rolling dice. So if I roll a dice one time, I got a 2. And then I roll it another time, I got a 6. And I roll it another time. So in total, rolling it quite a few times. What am I at now? 10, 14, 15, 17, 18, 19, 20. So rolling it 20 times there. That's what I have. You see I got 6 the most. I got 2 and 3 both 4 times. I got 1 3 times. I got 4 1 time, and I got 5 2 times. So if I were to put that into my chart, sorry, I will erase it. Oh, now oh, I think it was something like, oh, let me use my tablet. 6 4 4 3 1 2. Wrong one. So 3 1 2. So that's in total 20 times. Hopefully I mathed that right. So it says, how often do you think you should, oh, this is our individual table. So let's say we had a big class instead of our teeny tiny little class, and we had 20 people in it and we all rolled it 20 times. Well, that's 400 rolls. So I'm just going to put in 400. So 1, 2, 3, 4. So if we had 400 rolls, so if we now had our, how can I do this? Nope. Whatever. What you see, so 63, 66, 65, 70, 60, 76. So you can see that it started to even out. So if I'm looking, if you just kind of watch this chart, see how 3 started out pretty strong and then other ones are starting to catch up and it's starting to equal out. So eventually, I'm clicking 10,000s now. You see that they all start to have very similar numbers eventually, as there are more rolls, and we'll talk about why that is a little bit later. So for the class table, whatever, you can kind of skip over it, but the frequency becomes more evenly distributed. So it says, how often do you think you should receive a roll of 2 on a die? So we got on our individual table 4 out of 20 times, or about 20% of the time. But we anticipate that it should happen about 1/6 of the time, which is about 17% of the rolls. And the reason that we assume 1/6 of the time, again, is there's 6 faces on the die, on a dice, or the dice. So 1/6 of them is a 2. How often do you think you should get a roll of 6 on the die? So we got a 6 times, so 6 out of 20. So we would assume 1/6 of the time, but we got it more than that. So again, this is just based on random chance though. So we would assume that that would be our number. And if we looked at our chart now, if we looked at in total, we had, let me grab a calculator here. Calculator. So if I put in 45169 divided by 270400, you see we get 16.7, which is basically close to 17%. So as we have more rolls, we come closer to that expected value. Oh, I keep clicking the 20-2 one. There we go. So how does your prediction compare to the data the class received? Is there a difference? Yeah, both of these were not bang on. So 6 out of, if we look at 6 divided by 20 times 100, we got a 6 like 30% of the time. There is a difference. And so again, we got a 6 about 30% of the time. And so again, when we had the, whatever it was, 200,000 rolls, it was 17%. But when we have a really small sample size where we were only rolling it 20 times, we're going to be off on most of them. Like as an example as well, we would expect to get a 4 17% of the time, because again, one die has 1/6 of the faces are 4. So we would have assumed that it would be 17% of the time, but it was actually only 5% of the time. So 1 out of 20 is 5%. So the next part, sorry, I'll try to full screen this. So in probability, an event is any possible outcome of an experiment. Probability is the confidence that some event will happen, measured on a scale of 0 to 1. So this is important with probability. We're going to use the scale of 0 to 1. 0 means that the event is impossible, so will never happen. And 1, having a probability of 1, means that the event is certain or guaranteed. So probability can be written as a fraction or a decimal. So again, that's going to be either a fraction of like 1/2, something like that, or a decimal being between 0 and 1. So the probability of an event occurring can be determined experimentally or theoretically. So the big thing with this is usually when we're talking about probability, we're not going to use percentages. You saw with the last question, I kind of turned it into percentage eventually just for representation, but you see that I also wrote it as a fraction here, so 1/6. So instead of a percent, I could have written it as 0.17. So that's 17% as a decimal. Again, it's a number between 0 and 1. So the probability of an event can be determined experimentally or theoretically. So those are two different things, and we'll talk about what we have. So in the investigation above, the probability of a die face was found using a simulation, so using that GeoGebra one. So this is an example of experimental probability. So experimental probability is trying something out and using that as your data. So there are several ways to simulate experiments. Some of the ways are coin tossing, drawing cards, random number tables, lots of different things. Data collected to determine experimental probability will vary. So if I asked you to roll the die 20 times, you would probably get a chart that's different from what we had there. And again, that's experimental. So you would have got probably 6 different numbers there, because again, it's experimental. So this is why our class data varied, and each group would not necessarily get the same result if you repeated the experiment. The theoretical probability, though, is determined by calculating or counting using a sample space. It is based on theory, not a simulation, and there is only one theoretical probability for a particular event. If the outcomes of an experiment are equally likely, the theoretical probability of event A can be found by determining the ratio of desired outcomes to the number of possible outcomes. So this is what we have here. The probability of event A is equal to R divided by N. So R is the number of desired or favorable outcomes whenever we're talking about, and N is the total number of equally possible outcomes. So the probability of rolling a 6 so event A is rolling a 6. So our desired outcomes are rolling a 6. So there's one way to roll a 6. The number of equally possible outcomes. We know there are 6 possible outcomes and they're all equally likely for a regular die. So 1 out of 6. We could also have something like probability of rolling an even number. So an even number on a die, so we know we can roll a 1, 2, 3, 4, 5, or 6. So 2, 4, and 6 are what we're going to call favorable outcomes since we're talking about rolling an even number. So there are 3 possible favorable outcomes. So rolling a 2, a 4, or a 6. And again, there are 6 possible outcomes. So you can leave them as fractions, that's fine. You can convert them to decimals, but again, usually don't express them as a percentage. So I think we said this is 0.17 and 3 out of 6 is 0.50. So these are the 2 ways that we can represent probability. So that's the whole first lesson. There's a couple different questions in there. Make sure you compare with the key, which I don't know if I've posted yet. I will post it for you. Things you need to know. So a standard deck of cards, there are 52 cards. There are 4 suits. 2 of the suits are black, 2 of the suits are red. There are 13 cards in each suit. If we're talking about face cards, those are cards that have a face on them. So Jack, Queen, King of every suit is considered to be a face card. And when you're doing a question, a probability question that has the word or, you need to think back to set theory, or you add the 2 probabilities. If it's an and question, you'll see and questions, you multiply. So that's something that's important. So again, an or question, you're adding, an and question, you're multiplying, and make sure you're not double counting something. So please, when you do this lesson, compare with my answers. Before you move on to odds. There is a summary at the end, like there's 6 practice questions. There's a summary at the end, which is this one. So an experimental probability is found by performing an experiment and can change with each trial. So if I go and I re-roll the dice, if I reset and I roll it 20 times, 1, 2, you see we got different numbers than last time. So 6 is still my most common, but it's tied with 1, and it's a different set of numbers from last time. So that's our experimental probability. Theoretical probability is determined by counting or calculating. And does not change. An event is considered to be fair if all events are equally likely. And we'll only talk about that, right? If you're flipping a coin, it's the same probability landing heads or tails. We don't have some weird coins that somehow always land heads or something like that. Probability should be thought of as a fraction or decimal. And be between 0 and 1. So that is it. Do those questions and then move on to probability and odds.